Time, the ever-flowing river that shapes the fabric of our existence, has intrigued humanity for centuries. Its enigmatic nature has fueled the imagination of scientists, philosophers, and storytellers alike. One of the most captivating concepts that arises when we contemplate time travel is the paradoxical conundrum known as the grandfather paradox. Imagine for a moment that you possess the ability to journey through time, to traverse the eons and witness history unfold before your eyes. But what if, in the course of your temporal voyages, you were to encounter a contradiction so perplexing that it threatened the very foundation of causality itself? This is the essence of the grandfather paradox, a riddle wrapped in the enigma of time travel. The thought experiment goes like this. If the time traveler prevents their own existence by eliminating their ancestor, then how could they have traveled back in time in the first place to carry out the deed? Before delving deeper into the intricacies of the grandfather paradox, it's essential to understand the various theoretical frameworks that underpin the concept of time travel. Albert Einstein's theories of relativity revolutionized our understanding of space and time. According to these theories, time is not an absolute, but rather a dimension intricately intertwined with space. Special relativity posits that time dilation occurs at high speeds, while general relativity suggests that gravity can also warp the fabric of time. Certainly, Einstein had already tackled the concept of traveling into the future. Scientific evidence confirms that if an astronaut were to travel through space at 90% of the speed of light upon returning after just 1 month, more than 2 months would have passed on Earth, effectively propelling the astronaut into the future by over a month. While our current technological capabilities fall short of constructing spacecraft capable of nearing the speed of light, this phenomenon of time dilation persists. For example, if a pilot were to fly a Lockheed SR-71 Blackbird reconnaissance aircraft at a speed of 3,500 kilometers per hour for 18 minutes, upon landing, they would observe that their timepiece is 1 second ahead of those synchronized with Earth's time. While venturing into the future is no longer confined to the realm of myth, journeying back to the past remains firmly in the realm of speculation. Proposed within the framework of general relativity, wormholes are hypothetical tunnels in space-time that could potentially connect distant regions of the universe. Traveling through a traversable wormhole might offer a shortcut through both space and time. At the quantum level, particles can exhibit strange behaviors, such as superposition and entanglement. Some interpretations of quantum mechanics suggest the existence of parallel universes or branching timelines, where every possible outcome of an event occurs in a separate reality. The closed time-like curves through space-time loop back on themselves, theoretically enabling closed time loops. If the CTCs exist, they could potentially facilitate a form of time travel, albeit accompanied by potential paradoxes, such as the grandfather paradox. While these theories offer intriguing insights into the prospects of time travel, they also prompt profound inquiries into causality and the fundamental nature of reality. The grandfather paradox has perplexed thinkers for decades, leading to a myriad of proposed solutions and philosophical debates. In general, there are 2 representative explanations that attempt to reconcile this paradox. The Novikov self-consistency principle suggests that if a time traveler attempted to alter the past, their actions would inadvertently contribute to the events leading up to their journey, ensuring that history remains consistent. Some interpretations of quantum mechanics entertain the idea of branching timelines or parallel universes. According to this view, when a time traveler alters the past, they create a new timeline or parallel universe, diverging from the original timeline. Thus, the time traveler's actions only affect the new timeline, while the original timeline remains intact. Beyond the realm of theoretical physics, the grandfather paradox raises profound ethical questions about the implications of time travel on our understanding of morality and free will. Consider the ethical dilemma faced by a time traveler who possesses the ability to prevent a great tragedy, such as a natural disaster or an act of violence. While intervening might seem noble, it could also have potentially catastrophic consequences. Furthermore, the very act of interfering with the past raises questions about the integrity of causality and the sanctity of historical events. Moreover, if the past is immutable and the future predetermined, then do we truly possess the freedom to shape our own destinies, or are we merely actors on the stage of a preordained cosmic drama? Clearly, physicists alone can't tackle all the challenges we face. So, it's worth considering. If humanity aims to reach new heights in science and technology, does it need to take a qualitative leap in moral development? It's conceivable that as our civilization progresses, we may no longer grapple with dilemmas that alter the course of history. At that juncture, the grandfather paradox may naturally fade into obscurity. Perhaps only by overcoming this obstacle can a journey to the past become feasible.